Bright Tuty. Every student matters.
Hello students, welcome back. Today we're going to start with square and square roots. I hope you people are doing well at your homes. So here is a new topic, square and square roots. You know, you're already familiar with it, but there are many properties associated with it which you need to learn in this grade. So I would start with something that you are already familiar with. So here starts the introduction. So how will I be introducing this to you is, I know that you all know area of square. Do you know this? If you try to recall the formula, I hope you all can answer this. Yes, it is side into side, or I say s multiplied with s, and this is also written as s square. Clear? This is known as square of s. So from here only you can see what do we mean by square. A square is that, suppose I say a square. So okay, let us not discuss the definition first. I have some examples. Okay, so if I write 1 cross 1, it is going to be 1, right? If I write 2 cross 2, that is 4. 2 into 2 is 4. This can be written as 1 square. This can be written as 2 to the power 2. 2 square. Exponents you are familiar with. Then we write 3 cross 3. That is 9. That can be written as 3 square. If we write suppose a 5 cross 5, that is 25, and it is a square of 5. So if any number a is there, I multiply the number with itself. I get a square. Right? Generally we can write it. So what is a square? A square, like I say, this is the square of something. Suppose 4 is there. 4 is square of what? 4 is square of 2. So what is special about these numbers? 1, 4, 9, 25, a square, and so on. Any number we can have. So the speciality about these numbers is, these can be written as the product of number with itself. 1 can be written as a 1 cross 1. Right? 4 can be written as 2 cross 2. The number, its product with itself. Right? So these are known as square numbers. I hope the definition for square is now clear. So square numbers are such numbers that can be written as a number with its product itself. Right? A number multiplied with itself gives us a square number always. Clear? So these are known as your square numbers. So as we have done in the area of square, side into side is s square. So what we are doing, we are finding out the square of a number in area of square. Clear? So if I go with the definition of a square number, you can frame it in your own words. You can say, if m is a square number, right, then m can be, you can just write, then m can be written as, okay, m is a square number, or we say m is a square, suppose I change it here, of n, right? Then n can be written as m equals n cross n. Right? That means when we multiply n with itself, it is going to give us m, and that m is a square number. Clear? I think this is clear now. So here m and n, these both are natural numbers. You know what are natural numbers? Natural numbers start from 1 and go up to infinity. Right? Okay. Now one more thing that I would like you to notice here is, I would like you to tell me, for example, I say 32. Is this a perfect square? You know, these square like 1, 4, 9, 25 are also known as perfect squares, because we can actually find a number, when we multiply the number with itself, we will get one of these numbers, right? So I would like to ask that, is 32 a square number? Can 32 be written as a square of one number, as a number multiplication is in multiplication with itself? So let us try to find out numbers closer to it. So, you know, we were doing 1 square, 2 square, 3 square, 4 square will be 16, 5 square is 25, so 5 square is 25, and then if we do for 6, 6 square is 36. So after 25, The perfect square is 36 only. That can be written as 6 multiplied with 6, because we already have told you that m is a natural number, n is a natural number. There can be no number in between, like 1 and 2. Like after 1, the next number is 2 only if we talk of natural. So here, can 32 be written as a square number? Can it be called a perfect square? Can it be written as a number multiplied with itself? No, we can't write it, because 5 square is 25. 6 square is 36. Between 5 and 6, there is no natural number whose square we can write as a number multiplied with itself, right? So 32 is not a perfect square. Clear? Now, what we will do is, we see that between 5 and 6, there is no number, no square number exists. No perfect square is existing. So I would like you to, observe this thing. Just see here. If I write 1 into 1, that is 1. 2 into 2, that is the next natural number, gives us 4. Then 3 into 3 gives us 9. Then 4 into 4, 16. 5 into 5, 25. So can you think of the numbers up to 10? Like 6 into 6, 7 into 7, 8 into 8, 9 into 9, and 10 into 10. Can you fill the rest of the places? Just think. Try to calculate it. 6 into 6 will be 36. 7 into 7 will be 49. 8 into 8 would be 64. 9 into 9 is 81. 10 into 10 is very easy, 100. Right? So now we see that it is square of 1. It is square of 2. It is square of 3. It is square of 4. This is square of 5. Square of 6. Square of 7, square of 8, square of 9, and square of 10. Now between 1 and 4, between 1 and 4 I am talking, these are two perfect squares, can be written as 1 square, 2 square. So between these, this is there, these are the two numbers. Are these perfect squares? Can 2 be written as a square of some number? No. Can 3 be written as square of some number? No. So if you look here, we observe that between 1 and 4, 2 and 3 are there, and they are not perfect squares, right? We need to know, most of you people think that 2, which is 2, this can be written as square root of 2 multiplied with square root of 2, because 2 to the power half into 2 to the power half. You might have done exponents, so you will be adding the powers. Half plus half is 1, that is 2 to the power 1 gives us 2. So you are writing 2 as square root of 2 whole square. But we are talking here about natural numbers. Square root of 2 is not natural. That means we can't write 2 and 3 as product of a number with itself, and the number should be natural. Right? So we can't write them. Similarly, between 4 and 9, we have 5, 6, 7, 8. These are non-squares numbers. These are not perfect squares, right? So the number 1, 4, 9, 16, 25, 36 up to 100, these are known as perfect squares. Clear? What is the term that we have given to these numbers? It is perfect squares. Clear? Now, do you think that is there any number or any perfect square which is left between 1 and 100? No, these are the perfect square numbers that are there between 1 to 100. If I talk of 1, 4, 9, 16, 25, 36, 49, then it is 64, 81 and 100. These are the perfect square numbers from 1 to 100. Clear? This is how we have reached on to a conclusion that the number other than these number, right? The numbers which are other than these numbers are not perfect squares. They can't be expressed as product of a natural number with itself. Clear? Now, here is something that I would like you to answer. Find the perfect squares between 30 and 40. You have to find out perfect squares between 30 and 40. You know, whenever this term between is used, you don't have to consider 30 and 40. The numbers in between them are to be considered. So from 30 to 40, which are the numbers? 31, 32, 33, 34, 35, 36, 37, 38 and 39. So these are the numbers on which you have to make a conclusion, or you have to tell which numbers are perfect squares between them. Now we know that we have already learned that 4 square was 16 and 5 square was 25, and after 25 the next perfect square was 36 only. That could be written as 6 square. After it is 7 square, that is 49, right? So between these numbers there is only one number that can be written as product of a number with itself. That means it can be written as 6 into 6. So yes, it is a perfect square. So find the perfect square number between 30 and 40. So it is 36. This is known as perfect square. Clear? This is how you find it. Now in 50 to 60. So 50 to 60, you know 51, 52, 53, 54, 55, 56, 57, 58 and 59. So after 7 we have 8 square, right? After 7 what do we have? 8 square, that is 64. So after 49 the perfect square is 64. Do we have that number here? Do we have 49? No. Do we have 64? No. So no number out of these is a perfect square. So we'll write no number is perfect square. So out of these there is no number that is a perfect square. Clear? So this is how you find. You search the number near to that. Like 51, we see 49 and 64 are closer. Just before it is 49 and after it is 64. Okay, now we are going to start with properties of square numbers. This is a very important thing you need to keep in mind. The most important part is of the lecture is this only, that we are going to observe some very important property, right? Like first we observed what is a square number. The property is that it should be expressed as a number multiplied with itself, right? So we can know what is a perfect square and what is not. Now here I would like you to know, observe carefully what I write here. I write 1 into 1, that is 1, or we can directly write it as now 2 square equal to 4. Then 3 square would be 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64, 9 square is 81, 10 square is 100. Let us write from 11 to 20 also, so that the observation becomes easier. With more numbers we are easy with observation, or can reach on to some conclusion. So let us do with 11. So 11 into 11, that means square of 11 is equal to 121. Square of 12, and I would like you to suggest that you should remember the squares up to 25 or 30. At least you should remember them. It makes really easier task for us. 12 square is 144, 13 square is 169, 14 square is 196, 15 square is 225, 16 square is 256, square of 17 is 289, square of 18 is 324, square of 19 is 361, and square of 20 is 400. Right. So I would like to observe the unit place of all these square numbers. Okay, observe it. See, here we got 1, 4, 9. Then here it is 6, 5, 6, 9, 4, 1, 0. Right. So what are the digits, unit places that we have observed? 0 we have observed, 1 we have observed, 4, 5, 6 and 9. So these are the digits, right? Here also we have 1 written already, 4 written, 9 that is also included, 6 again included, 5, then 6, 9, 4, 1, 0. So you see the unit digit is always either 0 or 1 or 4 or 5 or 6 or 9. That means a square number, the number which is a perfect square, its unit digit will always be 0, 1, 4, 5, 6 or 9, right? So I'm writing here or not and, that is more appropriate to it. So we can have any one digit at the end. If a number is having these digits at the end, so can that be called as a perfect square? Just to see here, does any of this number, okay, end with 2, 3, 7, 8. Is the ending digit of these perfect squares like 2, 3, 7, 8? No. So there is no number whose square will have the unit digit as 2, 3, 7, 8. There won't be any number, right? So if we find that a number has 2, 3, 7, 8 at the end, that will not be called as a perfect square. Clear? So the square numbers will end with always these digits 0, 1, 4, 5, 6 or 9. Clear? So one property that we have learned is that a perfect square will always end in 0, 1, 4, 5, 6 or 9. So every number that has the unit digit as 0, 1, 4, 5, 6 or 9, can that be a perfect square? Not always, but we know that if it is a perfect square, then it's going to be 1, 4, 9, 6 and 5. The last digit, or I say the unit digit, can be these only, right? If you have 2, 3, 7 and 8, directly we can say that it will not be a perfect square. So here is one question for you. It is asking, can we say whether the following numbers are perfect squares? How do we know? Right, so can we say that it is a perfect square or not? Just to see here, what is the unit digit here? 7. So it will not be a perfect square. In the second one, we have 3. So it will not be a perfect square. This one is 8, not a perfect square. This is 2, not a perfect square. Right, what about 1069 and 2061? So for these four numbers which had the ending digit, or I say the unit digit, as 7, 3, 8 and 2, directly for these we can definitely say these are not perfect squares. But what about the fifth and sixth part that we were discussing? That means 1069 and 2061, they have the last or the unit digit as 9 and 1. So yes, the square numbers have ending digit as 1 and 9, they can have it, but we always need to check. So 1069, let us think of a number that is very close to it. So if we go for 30, so 30 into 30 gives us 900. 31 into 31 gives us 961, right? Now if we do with 32 into 32, that gives us how much? 1024. Right, so now we are coming closer to it. Now let us try with 33 multiplied with 33. So can you think what we are going to get after getting 33 into 33? 1089. This is the number we get. So after 1024, the perfect square is 1089, and that is a square of 33. Clear? So 1069 is not a perfect square. Similarly, you can check with 2061. So what we will do is 2061 we have to check. 2061, we are going to try a number that is closer to it. So what we will do is, we'll do for suppose 45. Okay, 45 into 45 gives us 2025, right? So that is very closer to it. Let us check with 46 multiplied with 46. Right, so when we do 46 multiplied with 46, we get 2116. So after 2025, we directly have the perfect square as 2116. So 2061 is not a perfect square. So it is becoming tedious for us. Yes, one thing that we know, if the number is ending with 2, 3, 8 and 7, definitely it is not going to be a perfect square. So directly just by looking on them, we can say that it is not a perfect square. But what about other number that ends with digit 1, 9, 4, 6, 0? So what we do with that is, we keep on checking, and this is one way of checking the numbers. As we go more about the chapter, I elaborate the concept more. You are going to learn very easy tricks just by looking on the number, or by calculating the prime factorization that you are already familiar with. We will come to know which numbers are perfect squares, and you don't have to think a lot about it, right? So one thing that we are sure of now is that if a number has 2, 3, 7 and 8 as the ending digit, it will never be a perfect square. Clear? And if it is ending with other digits than these 4 digits, then we need to check. And for checking whether a number is a perfect square or not, there are different ways. This is one of the way, I'll let you know another ways as we go inside the chapter now. So see here, they're asking, write 5 numbers which you can decide by looking at their ones digit that they are not square numbers. Just by ones digit, so we know if the number ends with 2, 3, 7 and 8, it is not going to be a perfect square and it will not be a square number. So let us write them. Suppose I write 4, 5, 7, 8. This is one number. You just have to keep in mind that the ending digit should be out of these 4. So we have to write any 4 number. I can write 5, 9, 7, 2. We can also write 9, 3, 5, 3 we can take. Then we can take 7 as the last digit. And you know these first 3 places can be filled with any number. Right, so these are 4. One more we can write 2, 7, 9 and then we can write 3 at the end. So these are the numbers, 5 numbers. There are infinite number of numbers that you can write which are not square numbers, or I say which are not perfect square, just by looking on these digits, because these are ending in 2, 7, 3, 8, right? So we can directly say that these are not perfect squares. If a number is a perfect square, it will have the digits as 0, 1, 4, 5, 6 or 9, right? But this is not sure. If a number, all the numbers that are ending with these, they're not perfect square. For that we have checking methods, right? Checking tricks we have. But we are sure of this thing. If the number ends with 2, 3, 7 and 8, if the ending digits are out of 2, 3, 7, 8, any one, we can say the number is not a perfect square. Right? Let's go ahead. Here is one more question. Write 5 numbers which you cannot decide just by looking at the unit digits. Now previously what we have written the numbers. Just by looking on them we were able to decide whether it's a perfect square or not, and here we have to write the 5 number which, if we have a look on just the unit digit, we can't tell whether it will be a perfect square or not. So we have just done 2061. Right, it has the last digit as 1, but it was not a perfect square and we had to check it, right? So similarly, you know, you can write the numbers with digit 1, 4, 5, 6, 9 and 0. Any digit you can write 1000, you can write it has the ending digit as 0, but we are not sure whether it will be a square number or not. We have to always check. So also we can write now 6, 1, 2, 4. 4 is the last digit. We can write 7, 1, 3, 6. 6 is the last digit. Then we can take one more with 9. 3, 4, 9, 9. So this is also having the unit digit. You observe the unit digit. Now you just by looking on them can't say that it will be a perfect square or not. These are square numbers or not. We have to check for that. But if it, in case we had 2, 3, 7, 8 at the end, then we are pretty much sure that it will be a square number. So these are square number or not, we need to check. We can't directly tell, right? Now here is one thing that I would like you to observe. There are numbers written, there are squares written for them. So we have written them till 50. Just to see how 50. We have written for 1 to 10 directly. Then 11, 12, 13. Okay, for 11 it will be 121. Then 12, 13, 14, 15, 16, 17, 18, 19, 20. Then from 21, 22, 23, 24, 25. Then directly 30, 35, 40, 45 and 50. So here the table is made in such a way so that you observe something as we did in previously, and we reached to a conclusion that if the number is having the last digit at 2, 3, 5, 2, 3, 7 and 8, it will not be a perfect square. So here also we are going to observe a very interesting property about square number. I would like you to read it carefully and see what you can observe about it. So let us start with something very easy. So I am going to collect all the numbers, okay, whose squares are ending in 1. So I see this is there, okay. Then after it, the number whose unit place is 1, this is 81. Then 121 we have the third one. Then we have 361. Then we have 441, and here we don't have any number. Right, and here we don't have any other number here also. So what we observe is, I see that 181, 121, 361, 441, right? These are all the squares, perfect squares that are ending in 1, right? Always ending in 1. So what we observe it, the numbers, right? It is 1, it is 9, here it is 11, it is 19, here it is 21, right? So we see if the unit digit is 1 or 9, right? So here it also 1, here the unit digit is 9, here it is 1. And So when we go like this, that means we observe if a number is there, okay, whose unit digit is either 1 or 9, okay, if a number is there whose unit digit is 1 or 9, its square will always end with 1. We have 1, its square is ending with 1. 9, its square is ending with 1. At last we have 1. 11, at last we have 1. 19, at last we have 1. 21, we have 1 at the end of the number. That means the ending digit is 1. So what we observe here is, if a number is there whose digits or which is having the units placed as 1 or 9, and we are going to do the square, okay, any number having 1 and 9 as the unit digit, if we do the square will always end in 1. More appropriately, we'll say that if a number has 1 or 9 in the units place, then its square ends in 1. I hope this is another property that you people have observed. If a number has 1 or 9 in the units place, you are always going to be sure that the ending digit of the square of its square will be 1, right? So here is a question that we would like you to answer. Which of these would end with digit 1? First of all, let us write the conclusion that we have. We had the conclusion, if the unit digit of that number is 1, okay, unit digit is 1 or 9, its square will end in 1, right? So here it is, the square number in this, the unit digit 123 whole square, the unit digit is 3, so will it end with 1, right? No. 77, its unit digit is 7, no. 82, its square, no. 161, yes, we see that the unit digit is 1, so its square is going to end with 1. 109, yes, we have the unit digit as 9, so its square will end in 1 only. Clear? So this is how questions would be asked based on some properties. So it is very important for you to understand the properties, and by observing only we are going to reach to all the properties. So what we observed in the table, that if the unit digit of any number is 1 or 9, its square will always end in 1. So here we have 123, 77, 82, 161, 109. If we do the square of these numbers, we see that the unit digit should be 1 or 9, then only its ending digit will be 1. The square of its ending digit will be 1, otherwise not. So 123, 77 and 82 can't end, or their squares can't end in 1 at the ending digit. Clear? In the similar way, we will observe some more patterns, right? Just to see here. Square of 4 is 16, of 6 it is 36, of 14 it is 196, of 16 it is 256. So students, I want you to observe that if a number has 4 or 6 at the ending digit and we are going to do the square of that number, that means its square will always end with 6 as the ending digit. So just see, we can see that when a square number ends in 6, so square number ends in 6, that means number is given, that is given as a square of something. So if that is ending with 6, definitely the number will end is with 4 or 6. The number is ending with either 4 or 6, or we can say if a number has 4 or 6 as the units place, then the square of it is always going to end in 6. Clear? So let us try and practice some questions. By that it will be more clear and you're going to learn the property. Here is, which of the following numbers would have digit 6 at unit place? What are they asking? Which of the following numbers would have digit 6? So here see, the square of 19. We know if a number has the unit digit as 9 or 1, its square always ends with 1, not with 6. So it will not be there in the list. Second is 24 whole square. So we know that if we do the square of 24, definitely if a number, we are doing the square of any number and the number has 4 or 6 as the ending digits, its square will always end with 4. It will always end with 6, right? Not with 4. And so this will be counted in the list. The third one is 26. You think about it. It has either 6 or 4. It has 6 as the ending digit. So its square will always end with 6, right? Now next one is 4, 36. Yes, its ending digit again is 6 in 36. Just see, it is 6. So definitely square will end in 6. 34, yes, the unit digit is 4, so its square will always lie with the ending digit as 6. Clear? So this is how we are, noticing the things in squares and making them as property. We'll be using them in questions, and they're really useful. When you'll start attempting the questions, you come to know the importance of these properties, right? So till now you might have a question in mind that why are we observing it? But yes, there are questions, which are really, these properties are really helpful in simplifying them. Okay, so two things we have learned. One is that if the number ends with 1 or 9, okay, as the units place, then its square will end in 1. The second thing that we have learned is if the number ends with 4 or 6, its square will always end with 6 as the units place. Clear? Now, here are some questions. They're asking what will be the ones digit in the square of the following numbers. So in this question we have to answer what will be the ones digit in the square of the following numbers. The first number is 1, 2, 3, 4. We are going to do the square of it. See, they are asking ones digit in the square of following numbers. So we are going to do the square. We know the number ends with 4. So 4 4s are 16, right? 6 will be the ending digit. Right? What will be the ones digit? 6. So here we'll write ones digit, and before that we are writing the number. In the second part we have 2, 6, 3, 8, 7. So 7 square is 49. So 9 will be the ones digit. Third, it is 8 at the end, you observe. 5, 2, 6, 9, 8. So if 8 is there, 8 8s are 64. 4 will be the ones digit, right? You just have to do the square and notice this one. Okay. Fourth one is 9, 9, 8, 8, 0. Square of 0 is 0. The next one, fifth, is 2, 1, 2, 2, 2. 21,222. 2 square would be 4. Clear? So we see that if a number is there that ends in 8 or 2, its square will always end with 4. Clear? So we are going to do the square of these numbers. Sixth part, 9106. If we have 6 as the unit place, then what happens? If 6 is the unit place, 6 6 are 36, the square will end with 6. Clear? Just now we observed the property that if the number ends with 4 or 6, its square will always end in 6 only. I hope this is clear. Let's move ahead. This is very important to notice, see, and very interesting also. You consider the following numbers and their squares. Okay, 10 square is 100, 20 is 400, 80 it is 6400. So you see the number of zeros increasing, right? When it is 10, it is 100, it is 20, it is 400, it is 80, it is 6400. Numbers are getting greater. See, if it is 1, here it is 2. Here it is 0, that is 1 0. Here we are getting 2 zeros. Here it is 1 0. Here we are getting 2 zeros. So we have 1 0 here and we have 2 zeros. That means if a number is there whose unit digit is ending with 0, definitely the square will end with 0, but it will have number of zeros double of that number. Right? Similarly, here we have 2 zeros. In the square of it, we have 4 zeros. Just see, we have 4 zeros here. Clear? That means the number of zeros is getting doubled, right? So always will we have even number of zeros at the hand in the in a perfect square? Can we have 1000? Can't we have 1000 as square of some number? No, we can't have. Perfect squares will always have even zeros at the end. Clear? We can say about what you can say about the square of even numbers and square of odd numbers. So as I show you a table that has 1 to 30 squares written. So we could have observed in that only. But I would like to give you certain examples, or I would like you to take random numbers. Suppose I take 1 square, that is odd, it is 1. Square of 2, it is 4. Let us take square of 30, okay, that is even. Or let us write it here. So 30 square is 900, it is even. Or if I do with 31, we get 961, that is odd. Okay, so you do square of any even number, you will always get even number. You do square of odd number, you're always going to get odd number. Just to see if we randomly if we generally take it, suppose 2n is a even number, right? The square of it will be 4n square. it is an even number, right? Multiple of 2. Now suppose I say you have 2n plus 1 whole square. So you will get 2n whole square plus 1 square plus 2 into 2n into 1, that gives you 4n square plus 1 plus 4n. So 4n square plus 4n plus 1. Just say this is a multiple of 2 plus 1 we have. So it is always going to be odd, it is always going to be even. So yes, we can say that if a number is even, its square will be always even. If it is odd, the square of it is always going to be an odd number. Clear? So if you see here, the square of which of the following numbers would be an odd or even, and why, right? So just by looking onto the number, if a number is even, its square is going to be even, and if it is odd, its square is going to be odd. 727, you know, you are going to do the square, and you know if 7 is the units place, the square of it will have 9 as the unit place, right? So definitely it will be odd. Okay, this one, it will be even because this is an even number. 269, it is odd, the square of it will be odd. It will be even because the last digit is 0. Clear? So 0 is even. So what we are noticing here is that if we have a number is even, if a number is even, its square will be even. If a number is odd, its square will also be an odd number. Here is another question. We have to answer what will be the number of zeros in the square of the following numbers. First is 60. I told you if you have 0 at the end, the square of that number will have even number of zeros, and that is going to be double the number of zeros in the number. So 60 is there, its square will be 3600. Okay, so double the 2 is the number of zeros that will be there in square of 60. So you don't have to solve it always, you just double the number. So here also second, I am solving for your ease. So 400 square is there, 4 4s it will be 16, and 1 2 3 4 zeros we are going to have, because we'll do what, 400 into 400. Okay, so we can write it as 4 into 100 into 4 into 100. 4 and 4 will become 16, and 100 into 100 is 10,000. So 4 zeros we are going to write. So if we have 2 zeros here, at the end we will have 4 zeros. Double the number of zeros in the number. Clear? A square number will always have even number of zeros. Clear? I hope this is clear now. So we have learned so many properties of squares. So this is all for this, and in the next lecture what we are going to discuss, we are going to learn about many different patterns, the triangular numbers that you are familiar with. So we'll learn patterns and relate squares with them, right? How, you know, there are very interesting properties of squares that we always have come across, but we did not notice it in your junior classes. So we are going to discuss them, and it is going to be very interesting in the next video. So stay tuned for it, and thank you for listening carefully. Thank you so much.